I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this June 2026 lecture series, we are going to discuss about needle and wire electrodes in bioelectric measurement and biosensors. See why this topic is important. Actually, our real world problem is neuromuscular disorders which affect millions in worldwide. And the affected persons are patients, clinicians, technicians, and industry people. If this impact is not solved, we may misdiagnosis and inappropriate treatment may occur. And the delayed intervention and disease progression, which may affect the results of diagnostic and uh, diagnostic results, and this reduces the quality of life. So we need to take an initiative. See here the solution. We have so much limitations in existing methods. See here I've listed a limited spatial resolution, low signal to noise ratio, skin impedance effects, and it cannot access deep muscles. And the clinical challenges are deep muscle access, selective motor unit recording, minimally invasive procedures, real-time monitoring. Here we have a high impedance, polarization distortion, limited durability, biocompatibility needs are technology gaps. See, here we are using needle electrodes. Here I have listed surface and needle electrode differences. Here we have parameters like signal strength, spatial resolution, invasiveness, deep access, as well as selectivity. See, this performance comparison, which uses signal quality and spatial resolution as main thing. See, introduction to needle and wire electrodes. See, what is needle electrode? Needle electrodes are invasive bioelectric transducers which is inserted into muscle or tissue. Same thing for wire electrode, fine connective wires for selective recording we use. The key characteristics which involves high selectivity, good signal to quality, low impedance, minimal tissue damage. Here the electrode structure, we have conductive core, stainless steel or platinum, and insulating layer, epoxy or PVC coating, tip exposed to conductive area, and connector, the measurement system. The connector which is connected to the measurement system. See the types of needle electrodes. First one is concentric, and second one is monopolar, and third one is fine wire. The applications involves a clinical EMG, superficial muscles, and research and long-term applications in biomedical engineering field. See, first one is your concentric needle electrode. Here we have central conductor wire, outer cannular reference, and single recording tip. We have only single recording tip. While compared with the monopolar, this has single conductive core, external reference electrode, and simple construction. Fine wire, which has multiple fine steel wires. Wires remain post needle, and hollow needle insertion also allowed. Here the advantages are high selectivity, low noise, good signal, and monopolar is cost effective, easy to use, and superficial muscles applications are involved. And fine wire, we have advantages like motor units selective and long-term monitoring, as well as minimal discomfort. See the electrode materials and construction. The common materials used are stainless steel, platinum, silver chloride, and polarization characteristics, which involves the formation of double layer, voltage offset varies, and limited ADC or DC, which also limits the common materials steel and platinum. And while compared with non-polarizable, minimal offset, DC compatible, and stable reference, and we use the common materials AG or AGCL. See the construction details, we have to concentrate on insulation, tip, as well as connector. See the diagram, electrode cross section, see the conductive core, the top of the needle, and we have insulation part in blue color, and we have connector base and tip. See the electrode tissue interface, the equivalent circuit model, and impedance versus frequency response also shown here, and then typical impedance values and factors affecting interface also listed here. See the working principle. First thing is action potentials. Extract the action potential. Second thing, electrode deduction. Third one is ionic to electronic transition. Finally, amplification. The signal flow, which represents muscle or tissue, starting from muscle or tissue, then electrode interface, preamplifier and filter, and finally display. Our main thing is we have to extract the signal and convert that bio signals into electric signals, and finally we'll give a high valued signal as output. See the applications in healthcare: EMG for neuromuscular diagnosis, nerve conduction studies, deep brain stimulation, and intraoperative clinical research. See here I've included student activity, think, pair, share activity for 5 minutes, collaborative learning activity for needle electrode. The topic focused on electrode characteristics, clinical suitability, and trade-offs in needle electrodes, needle and wire electrodes. First, the students should think about the topic by individual, and they have to discuss with their pair, and finally share their insights in class. And here I have included some assessment questions from GATE and industry. Finally, summary of our topic. Thank you.